This is section 9.4, compound events. Our objective today is to find the probability of independent and dependent events. Let's start with vocabulary. A compound event consists of two or more events. Independent events are two events for which the occurrence of one event does not affect the probability of the occurrence of the other. They don't affect each other. For example, flipping a coin does not affect the result of rolling dice. So if two events are independent, then the probability of the first followed by the second is the probability of the first times the probability of the second. Dependent events are two events for which the occurrence of one event does affect the probability of the occurrence of the other. For example, if I pull a random number from a bingo set, that affects the probability of pulling the next number. So if two events are dependent, then the probability of one and then the other is the probability of the first times the probability that the second occurs after the first. And I'll show you what that means when we get to an example. Let's start by deciding if these are independent or dependent events. First, you choose a card from a deck, put it back, and then choose another. These are independent events because I put the first one back. I could choose any card again. It doesn't affect the probability of the second. If I choose a card from a deck and then choose another without putting the first one back, that is then dependent because now for the second card, there are only 51 options instead of 52. C, you roll two dice at the same time. These are independent because those two dice do not affect each other. Letter D, a man walks into the Humane Society and adopts a kitten, and then you go in and adopt a kitten. That is dependent because that man took one of the kittens out of the options that you could have chosen. So, you and a friend play a game twice. What is the probability that you win both games, assuming that the probability of winning is a half? So first, are these events independent or dependent? They are independent events because the first game does not affect the probability of the second game. The probability of winning and then winning, we just take our two probabilities and multiply them. So we'll take the probability of a win times the probability of a win. Well, we know the probability of winning is 1/2 and 1/2. So 1/2 times 1/2 gives us a probability of 1/4. Try this one. Find the probability of winning and then losing, still assuming that the probability of winning is 1/2. So these are still independent events. We now just take the probability of winning times the probability of losing. So the probability of winning is 1/2, and in a game you either win or lose. So the probability of losing is 1/2. So our probability is 1/4. Now we are going to select a card at random from those below. The card has the letter M. Without replacing the M card, we're going to select a second one. Find the probability that we select a card with the letter A after choosing M. Well, these events are dependent because I did not put that first card back. So we need the probability of choosing an M and then an A. Since they are dependent, we need the probability of an M times the probability of A after M. The probability of an M, there are two M's out of a total of 11 letters, times, now pretend one of these M's went away now. It's in my hand, it's not an option anymore. Now we have two A's out of only 10 cards. So now we're going to multiply these two fractions together. 2 times 2 is 4. 11 times 10 is 110. Well, that simplifies down to 2/55. Probability of choosing an M and then an A is 2/55. Now we are going to select a card from a bucket that contains 26 cards lettered A through Z. Without replacing the first card, we select a second. Find the probability of choosing a C and then an M. We need the probability of C, then M. First of all, since I'm not putting the first one back, these are dependent. So we need the probability of C times the probability of M after C. The probability of a C is 1 out of 26 because there's a 1C and there's 26 options. Probability of M after C, well, there's one M, and now there's only 25 cards because I took one out. So now I multiply these two together, I get 1/650th as my probability. So I want you to try these two examples on your own. All right, for the first one, we want the probability of choosing a T and then an S. Well, the probability of a T is 2 out of 11. Then I take one out, and I have one S out of only 10 cards left. We can cross cancel here a little bit. Make that a 1 and a 5. My probability is 1/55th that I choose a T and then an S. Now we have two sets of 26 cards. We're going to find the probability of J, then J. The probability that the first card is a J is 2 out of 52 because there are 52 total cards in there and 2 of those are J's. Now I took one of those J's out, so there's one left. And I took one card out, so there's only 51 cards left. Now we're going to multiply these, but let's first simplify this first fraction to 1/26. So when I multiply, I get 1/1326 as my probability. And now we are going to pick a method. We're going to toss a coin 3 times. Probability of getting 3 heads. Well, these events are independent. So the probability of 3 heads is really just the probability of heads times the probability of heads times the probability of heads. Well, the probability of heads is always 1/2. So we have 1/2 times 1/2 times 1/2, and we get 1/8. In the last section, we did an example like this. Our first toss is heads or tails. We used a tree diagram, remember? Our second toss, no matter what my first one was, could be heads or tails. And my third toss, no matter what my second was, could be heads or tails. Now, when I list out all my options, I find that only one of them, only one of them is all heads. So there's 1 out of my 8 total options, the probability is still 1/8. So these two different methods do the exact same thing, and you can pick whichever one you'd rather do. Here's your assignment.